Hello and welcome to my student. Now today's lectures we are going to learn the points reactions of alcohols. The last times also we have seen some reactions of alcohols as like the hydration of alkenes, hydroboration of alcohols, hydroboration reactions of alkenes. So these reactions we have seen in last times. Now we are going to discuss the oxidation reaction of alcohols. Oxidation reaction of alcohols. Next we have seen the oxidation of alcohols can be done by using oxidizing reagents as like the potassium permanganate in presence of H2SO4 or other reagents like the PCC, pyridium chlorochromate, and strong oxidizing agents as like potassium permanganate. So these are the oxidizing reagents we are used for the oxidation of alcohols. But also one of the things which are very important, we have seen last times the primary alcohols, reduction of aldehyde to give primary alcohols, reduction of ketone to give secondary alcohols, and as like this reduction of aldehydes it gives primary alcohol, reduction of ketone gives secondary alcohols. Similarly opposite to this oxidation reaction, in oxidation reaction are done like primary alcohols or oxidations to use a carboxylic acids as the final products. Firstly aldehydes and then these aldehydes which are converted to acids. Similarly secondary alcohols are converted to the ketones, and tertiary alcohols also they will use the carboxylic acid, but such a type of oxidation reaction can take place at the strong oxidizing agent. Let's we have see some reactions of this. Firstly we have seen the oxidation reactions of primary alcohols. Oxidation reactions of primary alcohols. We have seen firstly the general reactions like these primary alcohols can oxidize to use a corresponding intermediate as like and after after removal of water molecules, which one? These hydrogens and these OH, removal of water molecules to get corresponding aldehyde. And after formation of the aldehydes, which on oxidation with oxidizing reagents and to give corresponding acid as the products and water as the byproducts. Similarly, other reactions we have seen are yes like the forming alcohol, methanol can treat with the potassium permanganate K2Cr2 potassium permanganate in dilute H2SO4. These primary alcohols like the methanol is firstly oxidized into these aldehydes like formaldehyde, and those formaldehydes which on oxidation with potassium permanganate like a K2Cr2O7 and dilute H2SO4 to get the product as formic acid, HCOOH. Right? Potassium permanganate is strong oxidizing agents and therefore reaction does not stop at the aldehyde stage, and therefore this aldehyde is converted into their corresponding acids. For examples, other examples we have take like this ethyl alcohol. Ethyl alcohol can treat with similar agents like potassium permanganate in dilute H2SO4. It converts into firstly aldehydes like acetaldehyde, and those acetaldehydes by using same reagents to convert this aldehyde to acetic acid. Similarly, other reactions also we have seen are here like such a type of alcohols can treat with oxidation of potassium permanganate in H2SO4. Then the product is firstly corresponding aldehydes like and then after formation of aldehydes which then convert into acids like this is converted into acids, and therefore primary alcohols are converted to the acids having the same number of carbon atoms, right? There is no decrease the carbon atoms. Here how many carbons is there? 1 2 3 4 and 5 carbons are there. Similarly in the products 1 2 3 4 and 5 carbons. For in aldehyde stage also we have seen is here, it is containing the same number of carbon atoms of aldehyde. It get the products in this primary alcohols. The other reagents we have seen for the oxidation reactions like these PCC, pyridinium chlorochromate. Pyridinium chlorochromate. These agents which are used mostly the reaction is stopped at the aldehyde stage. Means we have seen in potassium permanganate which does not stop the reaction at aldehyde stage. It means that the aldehyde is converted to acids. But those reagents which are helpful to the reaction stop at only and only aldehyde stage is not converted into acids. For example, this propanol propanol can treat with PCC in dilute HCl. Acidic conditions can be required for those reagents. Therefore, this propanol can treat with PCC, pyridinium chlorochromate, which convert into only aldehyde stage like CS3, CH2, C double bond O, then H. So only product as aldehyde. It is not converted into acid. Similarly, other reactions also we have seen here, like these benzyl alcohols. These benzyl alcohols can treat with PCC in HCl. Their product will be benzaldehyde. The product is benzaldehyde. It does not convert into benzoic acid. So this PCC, which are helpful to reaction, is stopped at only aldehyde stage. Okay. So next reactions we have seen the secondary alcohols. Secondary alcohols. In secondary alcohols, by using same reagents, the reaction cannot stop at the aldehyde stage. Similarly, we have seen for general reactions of secondary alcohols with the oxidizing agents. Those secondary alcohols can oxidation to use as intermediate as like and after removal of water molecules, it converts into ketones. Ketone having the same number of carbon atoms, right? Ketone having a same number of carbon atoms, and then after formation of these ketones, which on oxidations with oxidizing reagents, they will convert into the acid plus another acid. So such type of reactions can be done in presence of the secondary alcohols. Now we have seen here some examples of secondary alcohols like isopropyl alcohol. These isopropyl alcohols can treat with the potassium permanganate. Then what happens? It first will convert into ketones like CH3, C double bond O, CH3. And after formation of these ketones, which on oxidation with potassium permanganate, it is also strong oxidizing agent. So its ketone is converted into the acids like CH3, C double bond O, H. So it converts into the corresponding acids. Similarly, we have seen other reactions. Then after treat with K2Cr2O7, so what is the first step? Formation of the ketone. These secondary alcohols are converted to the ketones like this: CH3, C double bond O, CH2, CH3. What is the name? 2-butanol. And these 2-butanols, which can oxidations with potassium permanganate, to give one of the product is acetic acid CH3COOH, and other acid which one? Propionic acids plus CH3, CH2, COOH, propionic acid. So two mixture of two acids will be get the product. One will be acetic acid and other will be the propionic acids. Now we have see the reactions of tertiary alcohols. Tertiary alcohols which is not easily convert or not easily oxidize to corresponding acids. Some reactions also we have CRES like the oxidation with potassium permanganate. Next oxidizing reagent at potassium permanganate. KMnO4. KMnO4 it acts as the strong oxidizing agent. Therefore, this cyclohexanol they will convert into only ketones. It does not convert into the acids because the cyclohexane ring which are more stable and therefore which is not break. Other product like 2-butanol. These 2-butanols which treat with potassium permanganate. Alkaline potassium permanganate. These convert into directly ketones like the product is CH3, CH2, C double bond O, CH3. This directly is converted into the ketones. Now we have seen some other reactions of alcohols like the tertiary alcohols. Tertiary alcohols which is not easily oxidized by using the alkaline solutions and therefore they can be oxidized with the help of the strong oxidizing agents like the potassium permanganate. In first step, what happens? These tertiary alcohols are converted into alkenes and those alkenes in second step convert into ketone and after oxidation with this ketone they will use corresponding acids. Now detailed reactions we have seen are here slide. The for examples tertiary butyl alcohols, tertiary butyl alcohols are can treat with potassium permanganate, but they will require acidic conditions like H2SO4. Therefore, it first step convert into alkenes by removal of water molecules. And after formation of the alkene, they can treat with the potassium permanganate, the 4 molecules of oxygen or the potassium permanganate. They convert into ketones like CH3, C double bond O, CH3 plus H2O plus CO2. Okay, what is the first step? Tertiary alcohols are converted into alkene and those alkenes which are converted into ketone. After formation of the ketones, they can treat with the potassium permanganate. They convert into corresponding acids like acetic acids plus the H2O and also CO2 as the byproduct. So reactions are totally carried out in first step, in the second step, and in the third step. In first step, what happens? First we convert into the alkenes by removal of water molecules. And after formation of alkenes, the alkene is converted into ketones. And these ketones, which is converted into the carboxylic acids like acetic acid as the product. So tertiary alcohols, which is not easily convert or easily not oxidized but like alkaline solutions, therefore it requires strong oxidizing agent in presence of the acidic conditions, right? Now we have seen next reactions of alcohols like the preparation of esters with inorganic acids. Preparation of esters with inorganic acids. We have seen the alcohols are treated with organic acids, that times they will get the product as the esters. Like this ethyl alcohol, we can treat with the acetic acid, then the product is ethyl acetate as the esters. Such type of reactions also done in the inorganic acids. We have seen this type of reactions. Firstly, we are going to discuss the reactions of alcohols, general reactions for alcohols plus H2SO4, HNO3. So such inorganic acids are converted into the esters. Like firstly we have seen H2SO4 can treat with alcohols at 80 degrees centigrade. They can heat it and to get corresponding ester as like the ROSO3H. So alkyl hydrogen sulfate, alkyl hydrogen sulfate, which is called as the sulfation reaction. It means alcohol are converted to sulfate, which is called as the sulfation reaction. So such a type of reactions mostly used for the preparation of detergents. Like ethyl alcohols we have take like this. This ethyl alcohol can treat with H2SO4, which can heated with 80 degrees centigrade. Then sulfonation can take place at this CS3 CH2O SO3H. So ethyl hydrogen sulfate, ethyl hydrogen sulfate. So this number of reactions as like this, which are mostly used for the preparation of detergents. You know that detergents are alkyl benzene sodium sulfonates, right? These alkyl benzene sulfonates, which are on the basis of these reactions, we can prepare these detergents, and those detergents which can neutralize with the help of the NaOH or the calcium carbonate and to get corresponding sodium alkyl sulfonate as the mild detergents.